Okay, so if you're checking this the night of posting, sorry that this is so late. I had a issue with the last video. I recorded the whole thing and then somehow the file was corrupted, so that was fun. I'm going to go a little bit more into depth on this lesson. This is lesson 10, simplifying cubic roots, just because I want to do a quick review of what the difference is between a square root and a cubic root. Now, a square root looks like this, and a cube root looks like this. Same thing, but it's got a little 3. The difference is that a square root undoes a square. It undoes something like an x squared. Done and done. This is equal to x. A cube root undoes something like an x cubed. These cancel out, and this is equal to x as well. Okay? So when we're looking to simplify variables, right, clearly I'm looking for 2's or I'm looking for 3's in the exponent spots. So that's the difference with those. The difference with numbers is when I'm trying to factor a larger number. With square roots, we were looking for these numbers. We were looking for 4, 9, 16, 25, 36, right? So like we're looking for like 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. These are what we call the perfect squares. Those are the squares. But we're not looking for those anymore. Now what we're looking for is what we call the perfect cubes. We're looking for the perfect cubes. What that means is we're looking for numbers like 2 cubed. Now 2 cubed is 2 times 2 times 2, which is equal to 8. So that's one of our cubes. 3 cubed is equal to 27. 4 cubed is equal to 64. 5 cubed is equal to 125. 6 cubed is equal to 216. And the last one, 7 cubed, is equal to 343. That's not the last one, but it's the last one that we really have to worry about. We won't be dealing with numbers with factors any bigger than that. So, when I'm simplifying, these are the numbers that I'm looking for. The reason I'm looking for these numbers is because if I could like factor out an 8, I could rewrite the 8, change it into a 2 cubed, and then it has the right exponent, right? Like I was saying before, it cancels out 3's. So that's the idea. That's why we're looking for these numbers. So let's do a couple of example problems. The first one that I'm going to do is one that we did in class. Just do it over again so you have the explanation on video. You can slow it down if you want. If I'm talking too fast, you can back up, replay it. My recommendation is the same as it has been on a few of my previous videos, that when I write down the question, you do the question first. Alright, so pause the video and try the question yourself. Once you're done, unpause the video, and you can watch me do it and see if and where you went wrong or if you got the question right. So hopefully that's a learning experience. Watching me do it doesn't quite do the same thing. So this is how we're going to do it. We're looking for 3's. How do I know? Because of that 3 right there. We're looking for 3's. That means things like this. We're looking for things like x cubed or 2 cubed or 5 cubed, right? We're looking for cubes. That's what we want. So what we're going to do is we're going to break up the number. That number 875 has to be divisible by one of our perfect cubes or we can't simplify it. Now what are the perfect cubes again? You wrote them on your sheet and I definitely wrote them on mine. The first cube is 8, 27, 64, 125, and this is actually the guy that's going to work. So I'll show you. Like, how do you figure this out, Mr. Costello? I'm just going to bring up my calculator. I look at the list of cubes, and I just check what divides in evenly. Well, 875 divided by 8, nah, that doesn't work. Decimals. 875 divided by 27, decimals. 875 divided by 64, decimals. 875 divided by 125, awesome. So that means that 125 times 7 is equal to 875. So you remember those two numbers, and we'll break the 875 up and rewrite it. So I'm going to rewrite it as 125 times 7. You'll see in a second why, but for now I'm going to go ahead and break up a couple of the variables as well. M to the 5th, well, that's too big. I don't need 5s, I need 3s, right? The cube root is going to want a 3. Now, the analogy that I used in class is I said, imagine the cube root is like the bouncer. Everybody under here is waiting in line. They're trying to get into a club, they have a Sweet 16 to go to or whatever, and the bouncer's only letting you in if you have an invitation. Now, what kind of an invitation do you need in order to get through, to get off the line, and for him to let you in? You need a 3. So this M to the 5th he's not going to do. Bouncer's going to turn him away. But I can break up the M to the 5th into an M to the 3rd and then an M squared. Now look at how I did this. I know that I want the 3, so I pull 3 off of the 5. I had 5 M's here. Now I have 3 M's and 2 more M's. That still adds up to 5 M's. Alright? I'm going to do the same thing with the N. I want an N cubed. So since I want an N cubed, I'm going to break one off, and it's going to give me 2 N's left over. So check it. 2 and 3 is still 5. I'm going to throw the cube root back over all that. I'll simplify the number, and then we'll bring everything out. The reason we did 125, the reason it matters that you choose one of these perfect cubes over here on the side, in this little table over here, the reason that it matters is because 125 can be rewritten as 5 cubed. I'll rewrite everything else, just bring it all down. I know it's a lot. As long as you're careful and you're thoughtful, even if it's a lot, you'll still get it right. Now everything is simple. Simple as I can get it. I've got as many cubes as I'm possibly going to find. So the bouncer says, alright, anybody with an invitation, come on inside. Now who has one? This is the invitation. So the 5 says, hey, I've got an invite. The bouncer says, okay, give me your invite, go on through. So he hands over his invite, he loses it in the process, and he's allowed through. Now this M cubed over here, he says, oh, I've got an invite. The bouncer takes his invite, and he's allowed through as well. The N cubed follows behind, hands over his invite, and he's allowed in. Now it's important to notice here that not everybody got to go through. The 7 is stuck, the M squared is stuck, and the N squared is stuck. So when I rewrite it, I want to be really careful about what goes out and what stays under. I know that I had the 5 come out, right? The 5 came out. I know that the M came out. And I know that the N came out. Now everybody else is stuck underneath the cube root. So who's stuck? The 7 stuck in line. M squared and the N squared. And that's going to be my final answer. Okay, so even though like you might want to bring through an M squared, the bouncer's going to say, nah, sorry man, this M squared, you got the wrong invite, man. That's for a different place. That's not for here. So you're not allowed in. The M squared is stuck. He's going to stand in line, and so is the N squared right next to that 7. Now let me try a slightly different example that has a coefficient in the front. The example that I'm going to pick is this one. The 3 cubed 256 question. Let me check which question number that is. That's the bottom of the sheet. That is question 35. Okay, so we'll do question number 35 now. This guy looks different because he has a number in the front. That number doesn't make things complicated. It's actually pretty easy. That's what we call a coefficient. A coefficient just means it's attached with multiplication. He's going to hang out on the front until the very end when we simplify. He's not going to be involved. He's not going to interact at all. He's just going to kind of do his own thing. It's like he's like waiting in front the whole time while we do our thing with the rest of the question. Okay? So I'm going to simplify these, the number first, because I want to figure out which perfect cube goes into 256. Is it 8? Is it 27? Is it 64? Is it 125? And I'm not really sure what the answer is. So, I'm going to take over my calculator again. I'm going to say, alright, is 256 divisible by 8? Yes, it is. But that's a big number. Big number left over. So I'm going to see, maybe, can we use a bigger number? Let me see. 256, is that divisible by 27? Nope. 256 divisible by 64? Yes, it is. And that works a lot better. You want to use the biggest perfect square, or biggest perfect cube. You want to use the biggest. The biggest cube factor makes for less work. The biggest cube makes for less work. That's just how it is. We have less simplifying steps at the end. So we're going to change this into 64 times 4. So 256 becomes 64 times 4. I'm going to break down the exponents now. Remember that I want 3's. So m to the 7th, I can pull 3 m's off. I can pull another 3 m's. That's 6 m's. I have 7. So 1 more m. The n cubed, actually, is already pretty nice. The n cubed is already a cube. So I'm just going to rewrite him. Now I'm going to put the cube root over the top. Put the 3 back in front. And I can move on to my next simplifying step. Now, what was the reason I chose 64? It's because 64 is equal to 4 cubed. If I can't rewrite it into a cube, there's no point in factoring it at all. I'll bring everything else down. Times 4 times m cubed, n cubed, all underneath the cube root with a big 3 in front. Now I want to look at who gets to come out. Everything is simplified. We haven't done anything with this 3. He's just chilling. So 4 says, hey, I have an invitation. The bouncer says, hand it over, and you can go on through. This m cubed over here, he says, I have an invitation too, so hand it over, and you can go on through as well. This m cubed gets to go, and this n cubed gets to go. It's important to remember that they always hand over the invitation, right? So they don't come through with a 3 in the exponent. They give that up in order to get in the door. So let's look. A lot of stuff came out. So let's see what's still stuck underneath. Well, the 4 is stuck underneath, and so is the m. Everybody else got to come out. So let's take tally of who's still in front, okay? In front of the radical on the left, we still have a 3. And now we brought out this 4. Let me change colors so you can see it a little better. We brought out this 4, so 3 times 4. We brought out this m, so times m. Brought out this m, times m. We brought out this n. Who's stuck underneath? Just this guy and this guy. So underneath the cube root, there's going to be 4m. Now I can simplify, and then I'm done. What can I simplify out here in the front? 3 times 4 is 12. Let me change color again. So 3 times 4 is 12. M times m is m squared. I'll bring down the n. So times n, or just put the n on the side. Multiplication is implied. And now everybody that's stuck underneath. Third root of 4m. And that's how it works. So that 3 didn't do anything until the very end when I multiplied him by the other number. Otherwise, it's the same exact steps. If you have any other specific questions or any examples that you really need worked out or something you think looks a lot different, just contact me, ask me, and I can upload a video for you. Thanks, and good luck.